and good afternoon. I'm very pleased to present our research result in the first international conference of sapling materials. My name is Tae-Ho, and I'm a PhD candidate at the University of Tokyo, Japan. And today, I'd like to talk about entitled by sapling behavior by cementitious recrystallization of cracked concrete incorporating expansion agent. Before my presentation, I'd like to introduce the background of this research. This research is a relation with the foundation of the New Energy and Industrial Technology Development Organization of Japan. And the project title was Development of the Sapling Concrete. And our research group is like this, the University of Tokyo and Yokohama National University and East Japan Railway companies. And then our co-worker will be presenting their research result and this section. So if you have any interesting, so please join them. Okay. First, I'm going to talk. I will introduction to the fundamentals of the sapling materials in the civil infrastructure and main objective of this work. And next, I will explain the fabrication of the concrete beam and the concrete cylinders incorporating expansive agent and their experimental result. And finally, I summarize my talk. As you know, that as a construction industry has made a great stride in the construction material field over the past 3 or 2 decades, in particular in maintenance and repairing materials in civil infrastructures. These figures, today's Professor Broge already mentioned about this graph, and then this is you can see that is a life cycle of the civil infrastructures in the traditional design. So when it occurred cracks like this, so it need repairing for the maintenance according to time. So that meaning that is a lot of cost will be paid for the repairing. So by the duration gradually. However, in case of the sapling design, we guess that is a sapling crack will be repaired after minor damages like this. And then, especially in case of the underground infrastructures, we can use the maintenance-free method using sapling concept. And then, so this study aims to estimate of the sapling ability of the concrete beam incorporating expansive agent and low water to binder ratio, and secondary to estimate the effect of the various carbonates for the recrystallization of the sapling. This diagram schematically shows experimental procedure. First, we investigated concrete beam incorporating expansion agent compared to the normal concrete beam at the low water to binder cement ratio. And then we also investigated concrete cylinders using the various carbonates such as sodium hydroxycarbonate and sodium carbonate and the lithium carbonate. And then we also investigated the effect of the carbonates on the cementitious recrystallization in this research. And then I will summarize my talk. This diagram schematically shows a mixed proportion of the concrete beam and concrete cylinders in this research. In case of the EC means that as an expansive agent was replaced the ordinary Portland cement by 10 weight percentage like this. And then water binder ratio was fixed 0.25% in order to make the concrete beam at the with the low water to binder ratio. Next slide schematically shows the fabrication procedure of the concrete beam in this research. And then this is the draw of the concrete beam in this research. And we use the 4D10 rebars in order to give the compression and tension stress that induce the crack. So, and then we also measured the rebar strain during the sapling, and then we fabricated the specimen like this. And then this is the excellent result of the expansive agent. And then you can see that is it was composed of this product, calcium sulfate and calcium sulfur aluminate and CaO. This figure shows the impact of the self-healing in case of concrete beam using expansive agent. You can see that its initial crack was 0.22 millimeters, and then, however, after water supply, you can see that if the crack was healed by the rehydration product and re-expansion until 28 days, and in case of the normal concrete beam at the low water to bind ratio, you can see that also it was also closed by the rehydration product until 28 days. However, you can find the different ratio of the self-healing abilities between two concrete beams. So in order to clarify this phenomenon, we did the test as follows. This figure shows the inference of the reverse strain on the concrete beams in this research. Left side is a reverse strain of before loading, and the right side is a reverse strain of the after water supply. So in case of the EC, both case of the show the expansion occurred continuously compared to the normal concrete beam. And then we also investigated the relation between crack width and the healing, like this. And blue line is crack width of the normal concrete beam at the low water to bind ratio, and red line is crack width of the expansive concrete at the low water to bind ratio. Especially in case of the EC, you can see that there's a self-healing mechanism or formation of the rehydration product and the re-expansion. So we guess that from this result, expansive agent has the high potential for the self-healing design in the civil infrastructures. However, in case of the normal water to bind ratio, we cannot see the self-healing abilities even though incorporating expansion agent like this. So due to the sufficient hydration by surplus water for normal water to bind the concrete. So in order to give the self-healing ability at the low water to bind the ratio, so we did the test like this. This figure schematically shows the experimental procedure for the concrete cylinder test using the various carbonate. And then we also investigated motors for investigating self-healing abilities and using various carbonate. And then we did the test like this. And then after water supply, and then we measured this area. So this figure shows the effect of the various carbonate and the calcium sulforamide on the self-healing of cracks in this research. In case of the sodium carbonate and the lithium carbonate and the calcium sulforamide, you can see that is a cementitious recrystallization between the crack. And moreover, in addition of the calcium sulforamide and some other mixtures, they show the various crystal structures of the cementitious rehydration products in cracks are like this. And especially in case of the sodium carbonate and some additives, shows the best performance of the self-healing abilities in this research. And same EDS analysis result revealed that rehydration product was composed by like this product, such as calcium hydroxide and galerite, calcium aluminum silicate hydroxide, and hydrox AFM. So from this result, we guess that is a rehydration product such as hydrox AFM or heavy carbon aluminate and monocarbon aluminate and stringite is a very desirable for the self-healing design in the civil infrastructure. So finally, I'd like to show some videos. So how can we control the self-healing abilities by various rehydration products? In this case is this is specimen were already cured 120 days, and then we induced crack and no more potent binder ratio. So you can see that is a in this case it's a sapling type 1, and you can see that is a rehydration crystallization was occurred from 14 days, and we can see that is until 28 days, and then it was perfectly sapling like this. And then in this case is the sapling type 2, so we can control by the sapling abilities rehydration using the rehydration product. So you can see that is after 3 days, it was a healed start like this. So until 28 days, we can see that is we can find that like this. A little slow, but yeah, like this is until 20 days we watching this specimen, and then crack was healed almost like this, and then this video is just until 20 days. We already did until 120 days, 200 days. So next time is we can show that. Okay, and then so summary of my talk is as follows. First, the expansive agent considerably affect the sapling of cracked concrete and low water binder ratio when compared to normal concrete. Secondly, the addition of the carbonate, such as sodium hydroxycarbonate and sodium carbonate and lithium carbonate to normal concrete, contribute to the increase in sapling ability in the cracked concrete by the cementitious recrystallization and precipitation particles. In particular, when utilization the appropriate doses of the carbonate and the expansive agent, and sapling abilities in crack could be increased. Thirdly, CEMENTITIOUS analysis results revealed that rehydration products were composed of the various cementitious crystallization products such as AFT, sulfate AFM, hydroxy AFM, and calcium hydroxide and halide hydrate. Some additives were also actioned in the bonding disturbance of the calcium hydroxide and silicate ions at initial healing stage. This appeared to contribute considerably to the formation of the AFT or AFM phases, the same as crack breathing in cracks. Okay. This is our laboratory members at the University of Tokyo, and last year we attended the concrete competition. Okay, this was my presentation, and thank you very much. And if you have any question or comment and some co-work, so if you want, at any time contact us. So thank you very much.
손을